If you called the last video, you already closed your DNS leak. Good. Here's the uncomfortable part. Even with a clean DNS result and your VPN running, your browser may still be handing out your real IP address to every site you visit. Not your provider this time, the actual address tied to your home. And for this one, your VPN often can't help you. In one well-known test of 100 VPNs by VoidSec, nearly 1 in 5 leaked the user's real IP through this exact hole. The feature responsible is called WebRTC. It's built into every major browser. It runs silently and it bypasses your VPN by design. You can check it in 20 seconds and I'll show you how to close it, even if your VPN won't. Now, in this video, we're going to cover what WebRTC is and why it leaks, a live test, why your VPN can't fix it, the browser fixes and their catch, the architectural solutions, and the 30-second monthly checklist. Now, this is part 2 of the leak series. Full playlist is linked below and don't forget subscribe for part 3. What WebRTC is and what a leak is. Okay, quick foundation. WebRTC, Web Real-Time Communication, is the technology that lets your browser run video calls and voice chat without installing anything extra. It's what powers Google Meet, Discord in the browser, that kind of thing. It's built into Chrome, Firefox, Edge, Safari, and Brave. Billions of devices. But here's the problem. To connect you directly to someone for a call, WebRTC has to know your real IP address. It finds it using something called a stun request. That request goes straight out through your network interface, around your VPN tunnel, not through it. So, a WebRTC leak is this. Any website using about 15 lines of JavaScript with no permission prompt can quietly ask your browser what your real IP address is. And your browser answers honestly, even with the VPN on. The feature that makes video calls work is the same one, handing out your address to anyone who asks. The live test. Alright, VPN connected? Good. Alright, slow down and follow along. Open browserleaks.com/WebRTC. The test runs automatically. Now you'll see 2 kinds of address, local and public. Local ones starting with 192.168 or 10. Are your home networks. Harmless. The one that matters is the public IP. Now if that public IP is your real one, not your VPN's, you're leaking. Same double check as last time. Note your real IP with the VPN off, then reconnect and run it again. If the same address shows up while the VPN is on, the leak is confirmed. iPleak.net covers this alongside DNS and IPv6 if you want everything on one page. Now go ahead and drop your results in the comments. Clean or leaked? And if it's leaking, mention which browser you're using. Because this leak lives in the browser, not the network, and that information helps everyone else figure out which setups are actually safe. Why your VPN can't stop it. So why is this one different from the DNS leak? Well, because it doesn't happen at the network level, it happens inside your browser. Your VPN encrypts traffic going through its tunnel. WebRTC's stun request doesn't use that tunnel. It goes out through a side door, directly through your network interface. A lot of VPNs never even see it, so they can't block it. That's not a bug in one bad product, that's the design. VoidSec tested 100 VPN providers and found 16 of them leaked the user's real IP through WebRTC, nearly 1 in 5. The top VPNs have since added browser extension patches, but those only work if you install them. Keep them updated and use them on every browser on every device. The fix has to happen in the browser, so let's go through exactly how to do that. The standard fixes. So, browser by browser. When we get to yours, go ahead and screenshot it. First up, Firefox. This is the easiest. Type about config in the address bar. accept the warning, search media.peerconnection.enabled and set it to false. WebRTC is fully off. Works on Firefox for Android too. Chrome and Edge. No built-in switch anymore. Google removed the old flag, so you need an extension. WebRTC Network Limiter is Google's own. WebRTC Control is another reliable option. Install one, enable it, and done. Next is Brave. It's mostly handled for you already. Go to Settings, then Privacy, and set WebRTC IP handling to disable non-proxied UDP. Next up, Tor. Nothing to do. It disables WebRTC by default. Safari and iOS, the hard case. Apple forces every browser on iPhone onto WebKit, and there's no reliable native off switch. If you need it gone on iOS, Brave is the most consistent option available. After any of these, rerun browserleaks.com/WebRTC to confirm your real IP has gone. Now, the catch. Two of them, in fact. One, fully disabling WebRTC breaks every browser video call you have. No Meet, no Discord in the tab. Two, you just fixed one browser on one device. A new browser, a new phone, an update that resets a setting, and you're exposed again. Same sealing as last time. You're patching the seams, not sealing the container. Do you even need a VPN for this? Well, here's the sharper version of the point from the last video. For a WebRTC leak, a VPN isn't just optional, it's often the wrong tool for the problem entirely. The leak goes around the tunnel by design. Paying for a VPN doesn't close it. You're left flipping browser switches that break your calls, one device at a time, hoping nothing resets. What actually fixes WebRTC without breaking your video calls, without redoing the work on every browser, is stopping the fight with the browser settings and using a browser that's sealed from the very start. The fix at the source. Go log in. Now, same approach as last time, and the reason is the same. A VPN wraps a normal browser and hopes nothing leaks around the edges. Go log in builds each browser profile as a fully isolated container. WebRTC is handled per profile, so it can only ever report the proxy's IP, never your real one. DNS goes through the built-in proxy. Time zone, language, geolocation, and fingerprint all match the proxy location. There's no side door for WebRTC to exit through because the whole profile is sealed. You're not disabling WebRTC, you're handling it cleanly, so your calls still work. Setup is done in just 2 minutes. On the Go Login dashboard, create a new profile. Pick a proxy or paste your own. Paid plans include 2 GB of proxy traffic per month. Then there's nothing else to configure. The team's position is that the automatic settings are already optimal. Go Login matches the WebRTC output, DNS, time zone, language, and geolocation to your proxy IP. Go ahead and click Run, then before anything else, verify. Go ahead and open browserleaks.com/WebRTC or iphay.com inside the profile. Check everything. No real IP, WebRTC consistent, DNS clean, WebGL clean. Make that the habit before literally every single session. Now, Go Login starts at $9 a month with a 7-day free trial and a free plan covering free profiles. Link is in the description. Who this actually matters to? Well, it's the same people as last time with one addition. Marketing agencies running multiple accounts on one platform, a WebRTC leak can expose the same real IP behind all of them. And detection systems link the accounts and ban the batch. Affiliate marketers checking how campaigners appear from different regions. One leaked real IP and the data is worthless. Web scraping teams. This one is particularly relevant because anti-bot systems specifically watch for a real IP leaking through a proxy. WebRTC is one of the ways they catch it. Now, different operations, same rule. The only IP anyone should see is the one that you choose to show them. A WebRTC leak breaks that quietly, in the background on every site you visit. For anyone running an operation that depends on clean separation, testing is hygiene, not caution. The monthly checklist. Now, the same point as last time, a clean result today doesn't stay clean. A browser update, a new install, a reset setting, and the leak comes back without announcing itself. 30 seconds, once a month, do this. Connect your setup, open browserleaks.com/WebRTC and check the public IP. Confirm only your proxy IP shows, never your real one. Verify WebRTC is handled in every browser you actually use. Recheck after any update or new browser installation. And that's it. Now, you've now closed your DNS leak and your WebRTC leak, two of the main routes your real identity uses to get out. There's one more piece. Every other way your real IP can surface in one place with one test that catches all of them. That's the IP leak. The final part of this playlist and the one that ties everything together, check it out next. Run your tests and subscribe to stay ahead of it.